Hello everyone, welcome to my channel. This is Vijay Lakshmi. Today we are going to discuss about decision tree. So as we all know that this is the third module we are discussing, that is the decision tree. So decision tree learning model is one of the most popular supervised predictive learning model which classifies data instances with high accuracy and consistency. So here a decision tree is a type of supervised learning algorithm that is commonly used in machine learning to model and predict outcomes based on input data. So it is a tree-like structure where each internal node tests on attribute, each branch corresponds to the attribute value, and each leaf node represents the final decision or the prediction. So the decision tree algorithm falls under the category of supervised learning. They can be used to solve both regression and classification problems. So this chapter mainly provides a keen insight into how to construct a decision tree and infer knowledge from the tree. So here we are going to discuss about different kinds of decision tree models. So coming for the decision tree terminologies, so we have here internal nodes, that is decision nodes. Nodes in the tree where choices are determined by the values of particular attributes. These are branches on these nodes that go to the other nodes. And we have leaf nodes while constructing the decision tree. These leaf nodes are called as terminal nodes. So the branches termini, when choices or forecasts are decided upon, there are no more branches on leaf nodes. So here these leaf nodes are nothing but the terminal nodes, what we say while constructing the decision tree. And coming for branches or edges, so they are nothing but links between nodes that show how decisions are made in response to particular circumstances. Next, splitting. So the process of dividing a node into two or more subnodes based on a decision criterion. It involves selecting a feature and a threshold to create subsets of data. So these are some of the terminologies what we use, we are discussing now. So next is a parent node, a node that is split into child nodes. The original node from which a split originates is the parent node. Next we have called as child node. Nodes created as the result of a split from a parent node is nothing but the child node. Then we use decision criterion, the rule or condition used to determine how the data should be split at a decision node. So here it involves comparing features values against a threshold. So if you take any of the problems like ID3 or C4.5, based on some decision, we are going to choose a node as a root node, and then we are going to branch it as a sub nodes. So that is nothing but based on some threshold. Next, pruning. The process of removing branches or nodes from a decision tree to improve its generalization and prevent overfitting is called as pruning. Okay. Next, we have a root node, a decision tree's root node, which represents the original choice or feature from which the tree branches is the highest node. So here, these are some of the terminologies what we are going to use while constructing the decision tree. So this is also an important question for the exam. Next example, just see what is the root node here. So in the root node only, we are going to, based on some threshold value, we are going to split this root node into sub branches here. The sub branches nodes are called as decision nodes here, splittings here. So this is a decision node, and in between you may get some terminal nodes, or it might be a decision node. So these are called as terminal nodes. Okay. And the last what we have is called as what? Leaf node. The last level of the tree is called as what? Leaf node. Here in this level, this terminal node is the leaf node. So here this is the subtree, branch or subtree from the root node, like how we study in trees. Every tree is associated with a root node, and then you have intermediate nodes. These intermediate nodes are nothing but decision nodes, and terminal nodes are nothing but the leaf nodes. So we say that these are nothing but the leaf nodes. Okay guys. Next, two major procedures of decision tree. So what are the two major procedures of decision tree means? One is first building the tree, or how decision tree is formed. Okay, so that is the goal and the input we have to write for this. So this question you may get for 5 to 6 marks. What are the two major procedures of any decision tree? First is that we have to build the tree. Okay guys, then the what is the goal? The tree is constructed in a top down fashion. The process of forming a decision tree involves recursively partitioning the data set based on the values of different attributes. So the algorithm selects the best attribute to split the data at each internal node based on certain criteria such as information gain or Gini impurity. Okay, any algorithm, first we have to construct the tree. So to construct the tree, we have to choose the best attribute to split. So that attribute which we are going to select is based on the information gain or the Gini impurity. The splitting process continues until a stopping criteria is met, such as reaching a maximum depth or having a minimum number of instances in a leaf node. So the splitting process continues till we reach the leaf node. And what is the output of this building the tree is decision tree representing the complete hypothesis space. So this is the output of building a tree using any of the algorithm. Next, second is knowledge inference or classification. The second step, so given a test instance, infer to the target class it belongs to. We have to identify which target class it belongs to. So in order to classify an object, we need to start traversing the tree from the root. We traverse as we evaluate the test condition on every decision node with a test object attribute value and walk to the branch corresponding to the test outcome. So given we are going to construct a decision tree for the sample data set, and then with a given test instance, we try to parse from the root of the node till the leaf nodes and check whether whether this test instance belongs to class 1 or class 2. Okay, so we know that here we have always the target will be either class 1 or class 2, yes or no. So which the test instance belongs to which particular class is the expected output. Okay guys, so first we have to construct the tree. Second is we have to classify the test instance belongs to which particular class based on the decision trees generated. Next, why do we want decision tree? We have n number of, we have k and then n place, many types of algorithms are there, but still why we go for decision tree? Decision trees are widely used in machine learning for a number of reasons. First is decision trees are so versatile in simulating intricate decision making processes because of their interpretability and versatility. Their portrayal of complex choice scenarios that take into account a variety of causes and outcomes is made possible by the hierarchical structure. They provide comprehensible insights into the decision logic. Decision trees are especially helpful for tasks involving categorization and regression. They are proficient with both numerical and categorical data, and they can easily adapt to a variety of data sets thanks to their autonomous feature selection capability. So decision trees also provide simple visualization which helps to comprehend and elucidate the underlying decision processes in a model. So these are some of the reasons which made us to go for decision tree even though we have K and N base, etc. So here we have, it supports both classification and regression models, and it is more portrayal of complex choices. So we construct n number of decision trees so that it will be easy for us to take to model to design a model which makes better prediction. Now, what are the advantages of decision tree? See, this is an important question for external exams. So you may get for 5 to 6 marks, advantages and disadvantages. So it is easy to understand and interpret, make them accessible to non-experts. Okay, he need not be an expert, anyone can use this decision tree. And it is easy to handle both numerical and categorical data without requiring extensive pre-processing. Then it provides insights into feature importance for decision making. It can handle missing values and outliers without significant impact. Applicable to both classification and regression tasks, and it is very quick to train the sample data sets. So these are some of the advantages of decision tree. And next, coming for what are the disadvantages of decision tree? It is difficult to determine how deeply a decision tree will grow or when to stop growing it. Okay, so as the depth may increase. Okay, if training data has errors or missing valued attributes, then the decision tree constructed may become unstable or biased. So here, if you have any missing valued attributes, so if you construct the tree, so it might become the outlier, it may lead to some outliers, or it might be biased. If the training data has continuous valued attributes, handling it is complex and has to be discretized. So as this is what we have seen in C4.5, to handle the continuous data, we have to convert it into discretized data. It is not well suited for classifying multiple output classes. Okay, then learning an optimal decision tree is also known to be the NP-complete problem. So NP-complete problems, so here already we know that where problems can be solved using polynomial time, so which cannot be solved using the linear form of solving. Then complex decision trees include the potential for overfitting. So here it may lead to problems like overfitting and underfitting, and potential bias in the presence of imbalanced data. So potential bias means when we have missing values or some erroneous data means, then it leads to some bias. Okay, guys, these are some of the problems. So here NP complete means we want the problems to be solved in logarithmic time, but here it will take some exponential time to solve the problem. So that is one of the drawback of the decision. It's coming for entropy. So this is very important from here onward. Some of the terminologies what we will be using in decision tree to construct the decision tree. So here entropy. Entropy is a measure of uncertainty of a random variable. It characterizes the impurity of an arbitrary collection of examples. So the higher the entropy, more the information content. So here entropy is nothing but uncertainty of the random variable. Impurity, the output variable is not properly working. That is called as the impurity or the entropy. So higher the entropy, higher the uncertainty. Lower the entropy, lower the uncertainty. So here the impurity will be more and here it will be less. Suppose S is a set of instances, A is an attribute, SV is a subset of S with A equal to AB. Okay, then and values of A is a set of all possible values of A. Then for example, if you consider for the set X equal to AA, BB, BB, if you observe this, total instances we have here is 8 instances. Instances of B is how many? It is 5. 1, 2, 3, 4, 5. And instance of A is how many? It is 3. Now how do we calculate the entropy? The total is A. Positive, here number of B's, instances of B are 5 and A's are 3. Now to calculate the entropy, that is the impurity or the disorder of a set of examples S related to binary classification is entropy S is equal to minus P plus log P plus minus P minus log P minus. So the entropy equation here, we can consider the positive and negative instances, minus P log P minus P log P. So this is for positive instances and this is for the negative instances. So here P plus is a proportion of positive examples in S. Okay, S is some sample data set. P minus is a proportion of negative examples of S. This entropy equation can also be rewritten like this, guys. So instead of writing like this plus and minus, we could have written entropy of sample data sets is equal to sum of minus sum of sigma 1 to k pi log pi, where pi represents what? Here pi represents the number of positive instances divided by the total number of instances. That is total positive plus the negative instances. How many are there? Together it will be represented. So log P plus divided by P plus N minus this minus, here again we write P minus log, here again it is P plus N, okay, P minus log P minus divided by P plus N. So it's nothing but you can write the entropy formula like this, or you could have written like this. Okay guys, if all the examples belong to the same category means it might, if in a binary classifier it can be 1 0 or 0 1. All the samples belong to either class 0 or class 1 means then the entropy will be 0. If all the examples are equally mixed, that is you have 50% of samples belonging to class 1 and 50% of the samples belonging to class 2 means then the entropy will be 1. Okay, and entropy is equal to level of uncertainty, level of impurity. Okay guys, so entropy can be viewed as the number of bits required on average to include the class of labels. If the probability for plus is 0.5, a single bit is required for each example. If it is 0.8, can use less than 1 bit. So this is about the entropy, and what is the formula we use for entropy. You can go for this formula, the first one what we have shown here, or in general you can use this formula to calculate the entropy, and we have to remember when it will be 0 and when it will be 1 to solve the problems ID3 or C4.5. Next, coming for this example, just to understand the entropy, you see here in this one, this feature 1 has, we have 3 attributes, feature 1, feature 2 and feature 3. Feature 1 has 8s and 4 no's, and feature 2 has 5s and 2 no's, and feature 3 attribute has 3s and 2 no's. And this 5s, 2 number, 3s and 2 number, these are all nothing but the leaf nodes. Now consider feature 2. For example, if you take this feature 2, how many yes, positive instances we have? 5. How many negative instances we have? 2. Totally how many instances we have? 7. Now how to write the entropy formula for this? How to calculate the entropy of this feature 2? Okay guys, so here how we have written, what is the formula here? Minus summation pi log pi. Pi includes what? Already I have written p by positive instances divided by p plus n, positive plus negative. So log pi, that is. So here what we are writing, minus how many positive instances we have here? 5. So 5 divided by totally how many instances? That is positive plus negative. 5 positive and 2 negative, 2 no's here. So 5 plus 2, it is 7. So minus 5 by 7 log 5 by 7, log 5 by 7 minus how many negative instances you have? 2. That is pi log pi. So minus 2 by 7. So among 7, 2 are negative instances. 2 by 7 log 2 by 7. So substitute the values here, we'll get 5 by 7. This one 5 by 7 into, that is 0.71 into log 5 by 7 is 0.49 minus 2 by 7 is 0.28 into log 2 by 7 is 1.83. Just simplify this guys. So you will get entropy as 0.85. Okay, so this is how we calculate the entropy. That is entropy is equal to P divided by P plus N log P by P plus 1, and for the negative instances we take plus. So here we have minus here. So minus again here because it is minus pi log pi minus n negative instances divided by p plus n. Okay, p plus n log p plus log n by p plus n. So that is a formula what we follow to calculate the entropy. So this will be common for all the entropy. For feature 3, now how we are going to calculate the entropy here. See the second example. Here you have 3 positive instances and 2 negative instances. Totally we have 5 instances here. Now how to write the entropy equation here? Minus positive 3 by total is how much? P plus n, 3 plus 2, 5. So 3 by 5 log 3 by 5 minus negative instances are how many? 2. 2 by 5 log 2 by 5. And just substitute like how we did previously. Just calculate this. You can directly use the scientific calculator for this. And then you will get the answer as 0.966. Just a simple mathematics simplification. Just simplify this, you will get the entropy as 0.966. So then coming for the challenge or attribute selection. So how to select the attributes? So here in the decision tree, the major challenge is the identification of the attribute for the root node at each level. So this identification of the root node is known as attribute selection. This process is called as attribute selection. We have two popular attribute selection measures, that is called as information gain and the Gini index. So coming for the information gain, when we use a node in a decision tree to partition the training instances into smaller subsets, the entropy changes. Okay, so information gain is a measure of this change in entropy. What is the change in entropy? Is called as what? Information gain. Information gain measures the reduction of uncertainty given some feature, and it is also a deciding factor for which attribute should be selected as a decision node or a root node. So information gain is equal to what? Entropy of the sample set, entropy of the entire sample set, that is the data set, minus entropy of y by x, means in this how much is the impurity of x is present here. Entropy of the entropy information of the attribute, entropy of the parent minus entropy of the child attribute, what we say here. So EY holds the entropy impurity of the entire tree, and this holds the entropy of the subtree, sub node here. So for whichever node you are calculating the entropy, subtract it with the parent node. So this is what called as change in entropy, which is nothing but the information gain. Next, we can compute information gain like this also. So the information gain of an attribute A is expected reduction in entropy caused by partitioning on this attribute. That is, gain of S of attribute A is equal to entropy of S, entropy of the tree, minus entropy of SV by S, entropy of SV, where V represents a set of values. Okay, it's a subset of S. SV is a subset of S for which attribute A has some value V. Okay, so here we write this as SV by S, entropy of the attribute value present in this sample data set S. So the entropy of partitioning the data is calculated by weighing the entropy of each partition by its size relative to the original set. So partitions of low entropy lead to high gain. If you have lower the entropy, the gain will be more. Next, picking the root node. The goal is to have the resulting decision tree as small as possible. So the main decision in the algorithm is the selection of the next attribute to condition on. So here we have to select the attribute. So to select, we want attributes that split the examples to two sets that are relatively pure in one label. This way we are closer to a leaf node. So if you are pure in one label, means you have reached the leaf node. So the most popular heuristics is based on information gain originated with the ID3 system of Quinlan. Okay, Occam's razor is one of the scientists who proposed this ID3 based on information gain, how we can identify the root node and then identify the best split for branching so that we can reach the leaf node to make the predictions or the decisions. Next, coming for pruning. Pruning is another method that can help us avoid overfitting. It helps in improving the performance of the decision tree by cutting the nodes or subnodes which are not significant. Removal of unwanted branches is nothing but we call it as pruning. So it removes the branches which are very low importance. There are two ways of pruning. One is called as pre-pruning and another one is called as post-pruning. So coming for pre-pruning, we can stop growing the tree earlier, which means we can remove or cut a node if it has low importance while growing the tree. Okay, if the node has little importance, means then you can remove that node. Post pruning means once our tree is built to its depth, already we have constructed the tree, we can start pruning the nodes based on their significance. We can start removing the nodes already we constructed from that tree, whichever is not significant, you can start removing those. Pre-pruning means before itself, before constructing the tree itself, based on some decisions or based on some threshold value, we try to remove the nodes. Okay, so that is nothing but pre-pruning we say. I think guys you have understood. For ID3 here just we discussed what is decision tree, and in next coming videos I'll be solving problems on ID3 and C4.5 and card problems. Please don't forget to subscribe, like, share and comment.